Okay, so this section we wanted to talk about the graphs of sine and cosine functions. So what will be the graph of sine functions? So we wanted to find all the special values. So 0, pi over 6, pi over 3, pi over 2, 2 pi over 3, all these things. What will be pi over 6 actually? 30 degrees, 60 degrees, okay? Sometimes we also introduce 45 degrees here. But maybe we do not want to find too many values here. So why do we only stop at 2 pi? Because this is one period. Because after one period, what happens? The graph will repeat. This is what period means, yeah? So the graph will repeat. So we find all these values and connect all these dots, and it will give you this. Okay, so because the period is 2 pi, and what happened? So after this, you will have exactly the same before. Okay, both to the left and the right. So, and from this picture, we can immediately tell the domain is negative infinity to infinity. The range means what? The maximum y and minimum y is between -1 and 1. You with me? So that's good. Period is 2 pi. We talked about it before. And the function is odd. Odd means what? Symmetric to origin. Yeah, when you look at the picture, so it's symmetric to what? Origin. Yeah, so here. Yeah, okay. And the sine, so here it doesn't say clearly, sine negative x equal to what? Negative sine x, yeah. Okay, so the next thing we wanted to talk about is, so this is the graph y equal to sine x. So we want to talk about is what will be the variations of sine x. So what means variations of sine x? So sometimes the easy one is a sine of bx. Okay, so this is one example variations. So the first step, we wanted to identify the amplitude. What is the amplitude? So that is what the maximum it can go here. The period for here is what? 2 pi. And then find the values of x for the 5 key points. So, and the 3 x-intercepts, the maximum point and the minimum point. So what will it be? So 1, 2, 3, 4, 5. Okay, so these are the 5 key points. So the 3 x-intercept, you will only need to draw the picture in one period. Yeah. So the maximum and the minimum. And then find the values of the y of these 5 key points. What does this mean? This means, we want to find these points. So it's only the x value and then y value. This will give you the point. Then connect all these things together with what? The smooth curve. And then this will be one period. Yeah. And this will become what? One period. What will you do? Then copy it down, both to the right and the left. Okay, so we wanted to learn here is what will be the amplitudes and periods. How could we find it for a general sine function? So the amplitude will be what? The absolute value of the coefficient here. And the period always equal to what? 2 pi divided by the b. So 2 pi divided by the b. Okay? Actually, this picture is the picture, the desired picture for you to draw, to sketch the further pictures. Okay? So the examples here, they have a lot of, so many different steps. But, in the exam or in the homework, how could you tell which picture is correct? This. Okay, so like for example, y equal to 2 sine a half x. 2 sine a half x. What is the amplitude? It's absolute value of 2, which will be 2. What is the period? So what will you do? Is 2 pi divided by a half, which will be what? 4. Okay, and how could you sketch the graph? Okay, so what I will do, I will just draw one period of sine first. Just draw it. I will not label anything. And what do we have here? The amplitude is the maximum and the minimum, yeah? So here is 2. Then I want to label here to be what? Negative 2. And then what I will label here? Oh, it's 4 pi. It's 4 pi, yeah? Okay. And here, how could I label here then? That's what? 2 pi. Because that's a half of the period. And similarly, this is pi. This is what? 3 pi. Yeah. And then how could I do the rest of them? I just what? Do the rest of them here. Okay. So I can directly, I do not need to substitute all these values to find x and y. I directly can know. So what is the maximum here? It's pi 2. What is the minimum here? It's 3 pi negative 2. Okay, so I do not need to find all the plug in to find all the values maximum minimum. I can directly tell from the picture. Okay, or you can use the steps from the textbook. Okay, it's long. Okay, so you can choose 0 pi, 2 pi, 3 pi, 4 pi, and then find all these things again. Okay, so okay, so you can use the shortcut that I introduced to you too. Okay, so the next part that we wanted to talk about here is the sine of bx minus c. Okay, so there is one thing that will be super important. It's called what? The phase shift. Okay, so the phase shift is always what? It's the shift is always what? With respect to x. Is with respect to what? X. So this is why. Okay, so this is the same thing as the function transformation in Collier algebra. So you have to, if you have a coefficient of b, so what do you need to do? You have to factor the b out. Then you have a x. Then what do we have here? You have to what? C divided by b here. Okay, so this is what c, where is c over b come from? It's actually what you factor the b out. Yeah, so because b and b will cancel, it will give you minus c. Okay, so the shifts, yeah, so in Collier algebra, the shifts, all these things. X minus means what? Goes to the right, yeah? C or B, yeah? So this is why, and if it's what? X plus, that will be what? Goes to the left. Okay, so I typically always wanted to keep this thing is positive. If it's minus, right. If it's what? Plus, it will be what? Left. Okay, or you can remember these things. So I will give you another one. If it's c plus b, then that's left. C or b. So for here, I always think about this as positive numbers. Positive numbers, yeah. So if we minus something, it's go to the right. If we plus something, that goes to the left. Okay, plus a number. Okay, so we do not need to talk about this is bigger than 0, this is less than 0, all these things. Okay, so this is the same as the function transformations in Collier algebra. Okay. Okay, so then how could we draw the picture here? Okay, how could we draw the picture here? Okay, so What do we want? The amplitude 3. What is the period? It's 2 pi over 2 is what? Pi, yeah? Okay. And what will be the phase shift? It's always this number. It's pi over 3. Oh my god, this is not good. Phase shift is what? Pi is pi divided by 3. You also need to divide by the coefficient in the front, yeah? So it's pi over 6. This is shift to the right or left because minus right. Okay, so now let's draw the picture. So the first thing, what will you do first? You just draw sine. And your amplitude 3. Here is what? Negative 3. What is the period here? It's pi, yeah? So now, what do you want to know here? This is pi over 2. Here is what? You divide by 2 again, pi over 4. Are you with me? And what does this mean? You want to shift this what? To pi over 6. So what I will do, here is 0. So we want to shift this to pi over 6. Okay, so you didn't change everything there. So here is pi over 6. Then what do we have here? It's also here from 0 to pi over 6. And then this is from pi add pi over 6 too, yeah? So pi add pi over 6 too. So what do we have here? 7 pi over 6. Are you with me? So this is me, okay? And then you write down everything, all these numbers that you get here. Always what? Plus pi over 6. Everything, because it's shift to the right, means everything plus pi over 6. Clear? Okay, so this is the shortcut that I don't want to give to you. And you can, continue to see. Step 4. Okay, so you can see this is the picture that I'm talking about. So the first one is pi over 6, and finally is what? 7 pi over 6. And this one is 3, this one is negative 3. Okay, and then everything plus all these things. So what it will be? How could you get 2 pi over 6? You have what? Pi over 2. We used to have what? Pi over 2 there, yeah? And plus pi over 6. So what do we have? Common denominator 3 pi over 2 plus pi over 6. That is what? 4 pi over 6. And then simplify 2 pi over 3. So the 2 pi over 3 is the same as what we do? As the 2 pi over 2 plus pi over 6 there. Are you with me? It's the same thing. Okay? So, but I think our method is much easier. Okay? So the next thing that we want to talk about is what? Y equal to cosine x. Of course, you can choose all these values again. You can use, your unit circle or anything that you wanted to do. And we will know that cosine is like this. So it's not start from 0 anymore. It will be start from the top and goes down, all these things. Okay? The domain is the same, range is the same, period is the same. But what happens here? This one is even because it's symmetric to what? Y-axis. Symmetric to what? Y-axis. So when you fold it, it's the same thing. Okay? Okay, so these are the two pictures here. Okay, so and actually what do you notice? Your cosine x is actually your sine x shift to the left pi over 2. Because because here is what? Pi over 2, yeah? So if we move the picture to the pi over 2, it's right here. Are you with me? This is why sine x plus pi over 2, yeah? Plus means what? Left. Pi over 2. Yeah, clear? This is, you have all these things. This is to tell you this. Okay, similarly, for y equal to cosine x, you also have what? Period and, all these things. Okay, so let's see whether we can do this one really quickly. So negative 4 y equal to what? Negative 4. What is amplitude? Here is what? Absolute value negative 4, which will be what? 4. So the period here is what? 2 pi over pi, which will be what? 2. So it's 2, not in all these numbers again. Okay, so the tricky part here is, so this is what? Cosine. Yeah, what will be the negative cosine? Negative means what? Flip over x-axis, yeah? Okay, so when you flip over x-axis, what will be the picture look like? So this one goes to bottom. It will be something like this. Okay, so this is the tricky part. Okay, so I would ask you to remember y equal to cosine x. It will be look like what? This. What will be y equal to negative cosine x? It look like this. Okay, so this is the sketch. Okay, so now as before, what will we do here? The amplitude is 4. Here is what? The negative 4. We label this. And what is the period here? 2. If we do not have a pi, that's fine. Okay, so what will be the middle here? 1. What do you have here? A half. What do you have here? 3 over 2. Then done, yeah? I think you get everything that you needed. Yeah, so you can see a half, 1, 3 over 2, 2, a half, 1, 3 2 over 2. So it's a lot of work, but we know it immediately. And we found the y period of the function. And then the rest of them will be what? Repeat. Repeat. Clear? Okay, and similarly, you will do the phase shift too. Okay, and for the phase shift, I think I will leave it for you. So, but you also need to be careful. It's the same thing as bx minus what? C over b. You with me? And you can also remember, if it's plus, what do you want? Left. Okay, so I will not, and if you have minus, what happens? Right. Okay, so then you will do all these things again and then do the shift. You can get the answer. Okay, so what will be the plus d? Plus d from the transformation of the functions or shift of the function. This means what? Move up or down, yeah? Yeah, up or down. Okay, up or down, you after you do the picture, move it up or down. Okay, so when you do the amplitude period, do not, it does not affect at all. And then you plus or minus plus 1 as required. Okay, so maybe we can do it very quickly here. Y equal to 2 cosine x plus 1. So amplitude 2, period 2 pi. Yeah. So what do we want to do? We wanted to draw y equal to 2 cosine x first. What will be the cosine look like? Like this, yeah. So we label this 2. Here is what? Negative 2. Here is what? 2 pi. With me? So what will be y equal to what? 2 cosine x plus 1. This means everything goes up 1. Okay. So negative 2 plus 1, it will become negative 1. So it will be, the maximum will be what? 3. So it will be look like this. Yeah, so which will be this picture. With me? So this is how we do the graph the sine and cosine functions. Okay?